Hello classmates. Welcome to learn air pollution control technology. Last class, we talked about what fuels are available. In this lesson, we will learn about the combustion process of fuel in section 2.2. It can be divided into complete combustion and incomplete combustion. The main products of complete combustion are carbon dioxide and water. Products of incomplete combustion, such as carbon monoxide and hydrocarbons, black smoke and other products that require partial oxidation. If the fuel contains sulfur and nitrogen elements, will generate sulfur dioxide and nitrogen oxides. Partial nitrogen in the air may be oxidized to thermal nitrogen oxides. The main factors affecting the combustion process are 1. Ideographic, moderate amount of air. We need to provide sufficient air. Only fuel can fully burn. However, if the air volume is too large, will lower the furnace temperature, increase heat loss. 2. Ideographic, a sufficiently high fuel temperature. 3. Ideographic, required reaction time. 4. Ideographic, full mixing of fuel and oxygen. Usually, we refer to temperature, time and turbulence as 3 T factors. Setting up combustion equations. 1. Ideographic, air composition, 20.9% oxygen and 79.1% nitrogen. The volume ratio of the two is 3.78. 2. Ideographic, fixed oxygen in fuel can be used for fuel combustion. Sulfur is mainly oxidized to sulfur dioxide. 3. Ideographic, without considering the generation of nitrogen and oxygen. Nitrogen element in fuel during combustion, all converted to nitrogen gas. Calculation of theoretical air volume A0. Theoretical air quantity refers to the fuel per unit mass, calculated according to the combustion reaction equation. Obtain the amount of air required for combustion. It is called the theoretical air volume. The theoretical amount of air is equal to the carbon element in the fuel, hydrogen element, sulfur element, oxygen required for complete combustion, subtracting the oxygen content contained in the fuel itself. Conversion amount. In actual work, we often use the air-fuel ratio to characterize the amount of air required for fuel combustion. The air-fuel ratio AF refers to the amount of fuel required per unit mass for combustion. Air quality. It can be obtained through the combustion equation. Taking burning carbon as an example, 1 kilogram of carbon, the mass fraction of carbon is 12. Therefore, the molar quantity of 1 kilogram of carbon is equal to 1 kilogram, divided by 12 grams per mole equals 83.3 moles. According to the chemical reaction of carbon combustion, carbon plus oxygen generate carbon dioxide. 83.3 moles of carbon combustion require 83.3 moles of oxygen. 1 mole of gas corresponds to 22.4 liters under standard conditions. Therefore, the volume of 83.3 moles of oxygen is equal to 22.4. Multiply by 83.3 equals 1.865.9 liters. The oxygen content in the air is 20.9%. Therefore, 1 kilogram of carbon requires an amount of air equal to 1865.9 liters. Divided by 20.9% equals 8,881.6 liters. The idea of organizing and calculating theoretical air. Firstly, assuming the quality of the fuel. 2. Ideographic, according to the combustion chemical formula of carbon, hydrogen, and sulfur in the fuel. Find the required molar amount of oxygen. 3. Obtain the required oxygen, the corresponding number of moles of air. 4. Find the corresponding air volume. 5. Divide the air volume by the assumed fuel mass. We can obtain our theoretical air volume. 2. Ideographic, ignition temperature of fuel. It refers to the combustion of combustible substances in the presence of oxygen. The minimum temperature that must be reached. Only when the ignition temperature is reached, only fuel can burn. The common fuel ignition temperatures are shown in the table below. 3. Time and spatial factors of combustion. The length of time the fuel stays in the combustion furnace. The temperature inside the furnace is higher than the ignition temperature. The higher the temperature, the shorter the burning time. Spatial factors, size and shape of the combustion chamber. Different furnace types. To choose the most suitable combustion temperature, the higher the temperature, the shorter the burnout time. However, the temperature is too high, the production of nitrogen oxides will also increase. 4. Ideographic, mixing of fuel and air. Fully mix oxygen in fuel and air. It is also a basic condition for effective combustion. If mixed, insufficient combustion will result in incomplete combustion. The above are the 3 T factors that affect fuel combustion: air-fuel ratio, temperature, time, and mixing degree. Good. That's all we have to say about the fuel combustion process in section 2.2 of this section. Thank you all.